I guess we can start. So hi, I'm João. I'll be talking about automation, and I know it's a bit boring to be talking about automation this late in the afternoon, but hopefully you fill yourselves with sandwiches and some beer, so hopefully not everything is lost. So I am João Maria. I'm a site reliability engineer at Sky, working for a product called Sky Store. It's a transactional video on demand. Started out as a developer and then moved to an SRE position. I'm into bikes and shells. So I guess you can call me Batman, because either Batman or something like that. DevOps. You've all heard about DevOps by now, I guess. Anyone new to this concept? No? Any DevOps in here? You're a DevOps? Okay, nice. And developers? You have addition? So you just raised your hand once. Why? You're just a DevOps? Yeah, but you're a dev as well. Yeah. So the thing is with DevOps, I think that all of this integration between dev and operations can leverage a lot about using automation. So if we automate a lot of things, we get a lot of these things back. And I'll be talking about DevOps and what I think that shouldn't be done regarding DevOps further down this talk. But for now, I'd just like to leave an opinion regarding this. I really dislike having a dedicated DevOps team. I'll be trying to explain why. Regarding automation, this is the definition I found for automation. It's the technology by which a process or procedure is performed with minimal human assistance. So a bit about myself. I said I started as a developer and I started in a small call center and developing extensions for a Linux IP PBX. If you're interested in it, it's asterisk. So we had a lot of extensions. Extensions went to calls for operators, and then operators would have some sort of scripts they followed to try and resolve technical issues. So they were in fact support engineers, or at least support just because they're client facing. I saw the need to automate some of these extensions and parked calls and information to the operators. And then I started moving forward from a technical aspect and trying to resolve client issues to developing actively for that IP PBX. I then quit that job. I finished university, and then I started my own company. And having your own company, it's very, very good. You're able to be a CEO, a CTO, you're a developer, and you're a support engineer. You might be a janitor as well. You can be head of a senior buzzword specialist department, something like that. The downside of it is that you have to do all of that in just one day's work. So what do? You try and automate as much as possible. And then that was what I started to do. I started to create some shell scripts, some Powershell, and that's the first time I saw Powershell, and it was really powerful. Thank God it has power in its name. And then I started to collect a lot of scripts that helped me in my day-to-day work. And it made me a better developer, a better support engineer, but also a better marketing director. Yeah, it was director of myself, but still. Because I had the time to do all of that. And the great thing about automation is that it's consistent and it's deterministic. So I can do the same thing and I can replay it over and over again. And I can dedicate more time to create client-specific features and try and target better my clients. This was also the time that I came into contact with DevOps. I didn't know the word by then, but I was doing this actively. I was integrating at every commit to my own server, and my clients, or my set of clients, were able to see their websites as we did and as we built features to them at every commit. I then and I'll make a parenthesis here. It's nice because I really liked Agatha's presentation, and it really touched me because I relate a lot with that. I quit my own company because my wife was having a kid, and I needed more stability, and I couldn't work 24 hours a day, even with automation. So I had to change. And then I moved to a consulting company, and then quit that, and then went to Microsoft to be a support engineer. And then I was a support engineer for 1 year at Microsoft. It has some parallels to what Agatha was saying. I did enjoy it. We had a lot of automation as well. We had a lot of scripts. We were able to just create a full copy of a customer's database, an entire data center, to a side DC, where we can make all of the tests and then try and ascertain if the fixes were really targeting what we wanted, and then put that back into production. So fast forward another kid, and I went to Sky. And I went to Sky and I started as a developer. And I was fortunate enough to land in one of the wonderful teams that I have had the pleasure to work with. I might say it was the best team I ever had the pleasure to work with. And we were technically sound. We were very good at what we did. The problem is that we had some things that stopped us from delivering features faster. And one of those things was our dedicated DevOps team. So our dedicated DevOps team were the gatekeepers of our installers, our complete CI and CD pipeline, Team CET, and a lot of other tools that we used to automate delivery for our customers. What's the problem with this? The problem with this is that we want to go faster to the market. And we were good at what we did back then. We're still good at what we do, by the way. But we had to pass this thing. And it was somewhat a proverbial fence in which we passed our code into GitHub and it went to production. But we had nowhere to touch any of those pieces because they were not our own. They were totally outside of our domain. It was DevOps only responsibility. And that slowed us down greatly. So what we ended up doing was trying and get to our side some of that infrastructure, some of that automation, some of those scripts. And we started by doing something just plain simple. We did all of the scripts to deploy a solar installation. We do Zookeeper. Don't know if any of you is aware of the technology. Solar is an index over Lucene. So it supports full text search that we wanted for our SkyStore product. So we took that from the dedicated DevOps team and we inserted that responsibility into our own team. And with that, we were able to create all of the scripts, automate this, put this into multiple environments and into production, gather the knowledge from doing this, but also automating all of the things that targeted Solar itself. So Solar acts, and I'm going to shift a bit into developer. So if I'm going too deep, just wave your hand, please. We used for this piece, we used the CQRS, command query responsibility segregation. And Solar acts as a read model to our event source and to our CQRS system. So Solar as a read model has sometimes the need to be consolidated against our write model. And this meant that we had to create a new collection, target our customers to that specific collection, tear down the first one, consolidate it, and then shift it back. So we basically automated all of this. We had scripts to do it, we had code to do it. And that's a big thing, because automation is in itself code. And developers, and most of us are developers, we're already doing automation. The code that we do is automation in itself. And I'll be talking this a bit down the talk as well. I was still automating my own tasks at this time, and I'm still automating my tasks at this time. Anything that I have to do more than once, I probably create a script for it. We as developers have a Scrum team. And as a Scrum team, we have our board, and we fetch tickets from the to-do and get it into other stages. And then we need to create feature branches to target our trunk and then deliver functionality to our customers. So we have the need, because it's process wise, we have the need to create a branch that has the same name that our Jira ticket. So this is something that's tedious. I had to know what the feature I was going to work with, get the Jira ticket, and then create a branch with exactly the same name, and I had to do a lot of things to get this working. What's best than having a PowerShell script that does exactly this? It targets my Jira server with an HTTP request, has credentials in it, or I can specify my credentials. I get the ticket, I create the branch, and I start working on it. So it's plain simple. So I did this. This was to my own use, but we did a lot of other things. We started somewhat to automate our builds, and they were automated, but they were using TeamCity. And we started to take that out of TeamCity and creating a pipeline as code. First in simple PowerShell scripts, and then shifted to using Cake. Cake is a C# make-like thing. You can specify your scripts in C#, and then that gets compiled and it's run in Roslyn, which is the Microsoft C# compiler. So we ended up doing that, and then we realized that we had the ability to automate all of our CI pipeline. Or even still, we could automate our CD pipeline as well. And we would have our pipeline as code in exactly the same code base as our code. And we shifted from using TeamCity with all steps specified, because it was some other teams work, and they were the gatekeepers of that. We couldn't put our own tasks in TeamCity because someone had to wave their hand and say, yeah, you can put it there because it makes sense. And why did we have to do it ourselves? Because it was our own team's responsibility. We knew what we had to do to target our own component. And we have a lot of components. We have a lot of services, and services have different needs. We have database migration needs. For example, we used Solr. We used MongoDB. There were components that were written in Java or that targeted a different stack. We started shifting to .NET Core. So using Core, all of our tooling was different from using .NET Framework. And this enabled us to create further down the road, and this is somewhat new. I'd say we have around 3 months of this. We created a .NET Core custom template to Bootstrap a service. What we usually created services in exactly the same way. They were exactly the same as the one before. It had installers. We had some installation vehicles to do dog fooding, like chocolatey packages. It's for the ones of you into Windows and that normally work in Windows. Chocolatey is a Windows package manager. It's almost like apt-get, for example, or yum in Fedora. So we created our packages for Chocolatey. We created Docker images. We created our installers and a multitude of installers, be it configs, be it binaries, and so on. And we had to deliver these to a specific folder, and then our CD pipeline started. But the fact is that our bootstrapping and our baseline for a service was exactly the same between one and the other. And that took a lot of time indeed. So we went from 2 weeks, and this is not conservative, by the way. We went from 2 weeks to bootstrap a simple service with no core in it, so no features in it, just plain baseline, to around 10 seconds. We can just do .NET new, SkyStore service, and then we have it all. We have a complete service, be able to run with a self-hosted web API that has monitoring in it, has self-checks, has information of the assembly that's running, has the entire CI pipeline in it. So we can just go and, well, go into the shell and type .NET new SkyStore service, and we wait 10 seconds, not 2 weeks, and then just type /build.ps1. And then we get what? We get NuGet packages, we get Chocolatey packages, we get all of the installers, we get Docker images, we have code coverage in it and targeting Solar, for example. But we have one other thing. It's not in this slide. We have one other thing. We can shift from using TeamCity. We're not using any of the features in it. We just have build agents, we have a server, and then we call a PowerShell script. All of the other things are completely automated. And this is a generic pipeline, but it's extensible in itself because every team has its own specific needs. We have some components that use CQRS and have read models that target Solar or MongoDB. Some others target SQL Server. So perhaps someone will use Entity Framework and data migrations. Some other will use a specific build step to migrate Solar, for example. So not all of this is easy to do. And that's the main thing that that really drives my nerves, is what to do and what not to do. And I still have difficulties in this. Because there are a lot of advantages and disadvantages in automation. But normally, and my experience tells me that the advantages outweigh the disadvantages. But there's some things that we need to really address and that we need to think about. And that's possible infrastructure lock-in. It's one of the biggest, I think, at least in SkyStore right now. I'll just give you an example of infrastructure lock-in. And this is one of the other reasons I really dislike specific and bounded DevOps teams. Because normally they try and create, and it's nothing wrong in doing it, but they have a different view of the domain they're working with than the developers have, and that the team that's working on the domain has, and they have different concerns. So they built things that were really meaningful to them, but they have nothing to do with the domain that we're using. So, and this precedes me, so please don't ask me why they did it, but we have a lot of dashboards built around our logging. So we drive logs from, we drive dashboards from our logs. We drive operational view from our logs. We drive NFT tests from our logs. We even have monitoring over our logs. What's the downside of this? Is that now, there was one time when we wanted to, and we use Splunk for log aggregation, and we wanted to migrate Splunk. this was not easy to do. This was not like taking down some search heads and then building them up with a different version. No, it had to be carefully thought out. It had to be rolled out, and it had to be reasoned with or reasoned about to create specific rollbacks in case something breaks. And why did they have to do it? Because we had our monitoring over this. We had load balancing over our logs. So if a search had failed, we would probably switching data from and customer HTTP requests from one data center to the other. So this was not something easy to do. And the work to do this right now is humongous. We cannot shift from using logs for all of our things. I have two colleagues in here and some other, he's not paying attention. Noon, you're here, right? Noon can vouch for me as well. It's really, really hard, and we still don't have a plan to do this. We cannot shift from using logs to drive all of this. So we're locked into our infrastructure. We cannot shift from using Splunk. We cannot have anything more than Splunk because it drives the entire infrastructure from that from the bottom to the upper tier. And that was a decision made by our DevOps team and architecture and, well, a lot of people, but they were outside of the domain. They tried and automated something, but they were not into it. They didn't know what to automate. They didn't know the process. And this leads me to one other thing. It's the paradox about automation. And the more efficient the automated system, the more crucial the human contribution of the operators. Humans are less involved, but their involvement becomes more critical. And this happened, and this still happens. So we automate something, and we forget about the whole process. It's automated. It works. It simply works, and we watch this every time. And people say this. It simply works, and it's good because it simply works. But then we start to our knowledge about the process and about the domain start to fade. And as team members leave the team and the deciders start to leave the team, so does the knowledge. And then we end up not being able to maintain our scripts or being able to intervene as something goes wrong. And that's one of the disadvantages as well of automation. The fallout can be wider, much wider than with human intervention and manual steps. And then we need operators to know the whole of the process to intervene when it's needed. But that's a paradox in itself, right? But do we want to do it? I don't know if we do want to do it. Probably, again, the gains outweigh the disadvantages of automation. But not all of the things can be automated. Or let me rephrase that. There are a lot of things that can be automated that I think shouldn't be automated. And we need to reason about what needs to be automated and what it's just a nice to have. This is difficult to do because automation in itself requires additional automation. We just don't automate part of our CI pipeline. It will mean nothing to us. We still have to go in there and click on buttons. We don't want to click on buttons. We want to push something into GitHub, and that will get into production. And it will be customer facing. So we don't want to get into that and click on buttons. So we want to automate the whole of the process. Should we do it? Perhaps. CI/CD pipelines are normally deterministic. We want that to be reproducible. We want to do a whole lot of them. So we want to integrate small chunks and a lot of them daily, hourly, if you're into it and if your infrastructure supports it. So what should we do? We should automate repetitive but well-known processes. And why well-known processes? Because we need to know all of our domain. We need to really know the process because we start to forget about it because it's automated. And then when we need to intervene, we really know the process. If the process is somewhat unknown, or needs human intervention, or needs some sort of reasoning, or is subjective, then we shouldn't do it. Then the gains won't outweigh the losses that we'll probably have if something fails or if something breaks. There's one other thing we shouldn't automate, and this again is a little bit shifting to developer role. It's code. Some people have, if it's the need or it's the will to automate all of the things that exist, and try and automate code. What's an example of code automation? It's frameworks. So we try and build frameworks. Why? Well, it accelerates the teams. It accelerates the developers. It has all of it there. We can just use it. It simply works. No, it doesn't. It doesn't, because we then need to adhere to the design of that specific framework. And that's the same thing with automation, by the way, because we've built a CI pipeline and we had that decisions. Anyone that will use our CI pipeline will need to adhere to that same decisions. For example, we have a specific structure, folder structure. We have source and we have tests. If we want to break this, it's not going to be easy. This is from the ground up. There's a lot of things that we can do and can change, and it's extensible in itself and configurable. But some other things, some designs that are built in the bottom of this automation cannot be changed or are not easily changeable. And that's even nastier if we do it in code, because you'll probably end up finding some domain that will never adhere to that specific framework. Then we have one other thing, is that as we start to automate things, and it's the same with code, we try and reuse things. And as long as we try and reuse things and don't reason about what we are doing, we're doing something wrong. Because we will adhere to something that was designed by another team in another area that had no knowledge about our process or what we were meant to do. So I ended up talking about the challenges, but the process should be easy. Well, it is easy. It has 3 steps. We should automate, we should test and maintain. What's the wrong about this? What's so difficult to do about this? Well, all of them. Why? Because we don't know what to automate. Most of the times we try and automate anything and everything, or we just do some specific thing just for our team. And then we're not aiding the rest of our teams. So, and we have an initial cost to do this. And if we have an initial cost, it might as well serve other teams as well. But then we don't want to go all the way, right? Because too less, and we will probably end up seeing nothing. It's like automating just a small step in our CI pipeline. If we automate more than what we needed, there's some more things to maintain, there's some more things to reason with, and probably someone unaware of the decisions will reuse our script and break something. And this is something that we end up getting at our day-to-day work. Test. And test is in yellow because it's harder to do than automation. Automation is simple. We just get our PowerShell script, we get our Bash script, we do whatever we want, Dockerfile, Helm chart, you name it, Puppet script, and you just automate something. What's the wrong with testing? We normally don't test our automation. Or if we do it in an ad hoc, iterative, hands-on kind of way, trial and error kind of way. We don't put the same effort in testing automation that we do in testing production code. So normally we do TDD, we do acceptance testing, we do contract testing, we do unit testing, and some other testing. We don't do any of that to automation. We just create a script, run it, did some side effect. Oh, okay, let me just check that. Okay, it's good. Yeah, it's good. Okay, you can ship it. Yeah. ship it like it's hot. And then some other team will take that script, run it in a different scenario, almost the same, but with a small difference, and then it breaks. And then you go back, oh, okay, let me test it, and ship it again. We're not putting the same effort in testing our automation that we do in testing code. And I don't know why, to be honest. It has a larger fallout, or it can have some larger fallouts than even our code. Because if we're not testing our CI and CD pipelines accordingly, and as it should be, we might break all of our builds. And then in a microservice, well, we're building up a lot of services. We're shifting from a monolith to a lot of services, and we have a lot of builds. And if they all reuse the same scripts, and if we break one build, we break all of them. So we, in fact, end up having nothing to show to our customers. That there are no hot fixes, no features, anything getting into production. Because someone, well, just made a small typo or something in our automation script. Will probably have no versioning. Some of them are in source control, some of them are not. Some of them are copied over to one service. Some of them are changed to that specific need. And that leads me to maintainability. It's not easy to maintain a lot of scripts. And we have to address some of these questions. Well, and there they are. Automate, test, and maintain. Deciding what to automate, how and to what extent. To not becoming hostages to our own automation scripts or infrastructure. If we break one script, we might end up having no components getting into production, and we are in fact hostages of our own automation. And this has even greater expression if we are reusing scripts that were not built on our team to our specific needs. They might have been created by someone 4 or 5 years ago in a specific DevOps team, for example, and we have this already. Today, he's laughing. Today, we're using scripts that we don't know what to do. They don't know what they do. We don't know what was the reasoning to create those scripts. What were they built to automate? We don't know that. They need to be called. Why? Because there's another script that calls them. Why? Because we have an installer that calls them. So, and this is cascading down the way to the bottom, and we don't know how to traverse this. We don't know what to do because we haven't built our own scripts. And that's the reason why I think we probably shouldn't be reusing scripts all the time. It's, for me at least, it's better to have a multitude of different scripts, and having to maintain a lot of scripts for specific needs than to maintain 1 or 2 or 3 scripts that are never 1, 2, or 3. They're all like 300 scripts all built in together and calling each other that support all of our processes. It's not something that we do. We don't do this in code. No one does this in code. Anyone that tries to create a framework will end up getting screwed up, because that framework won't target a specific need. That's the same with automation. That's the same with our scripts, and we should think about it. So during all of this process, from developer to site reliability engineer, and to my day-to-day, try and support our teams, try and think about what to automate, how to automate it, and how to help the teams doing it. What were the lessons learned of all of this, and is it worth it? Was it worth it? Yeah, it is, but it comes with a cost. And if you want to start and automate things, you should do it yourself. That's the thing. Don't delegate on someone else to do it. Don't delegate on a DevOps team to do it, on an infrastructure team to do it. I know you have an infrastructure team, sorry for that. You can aid the developers with specific things. Don't just build the tools and then don't just build the scripts and then ship it to the developers. It won't work. They won't gather the knowledge about what was done and what were the decisions. Decisions have to be bottom up. It cannot be someone from architecture or some CEO, CTO, and just say, no, you have to automate this. No, it doesn't work that way. Developers know what needs to be automated because they're the ones working with the tools and they're the ones doing all the work. Well, all the work at that level, at least, which is most of the work. And they're the ones that should be building their own tools, their own automation scripts. They're the ones with the knowledge on the domain and the knowledge on the process. They're the ones better suited to dive in when something wrong happens, right? When there's a failure, they're the ones that know what the fallout is, where and what will be targeted with that specific failure. They know what to do. It's not someone from a dedicated team that knows what has been done with their scripts, because they probably have changed in the meantime. They were created 4 years ago. Someone, like 20 people, changed them already. They're completely different. And they were adapted to an ever-adapting code base, an ever-adapting process, because things are not static. That's one of the things that it's hard to do with automation, is maintaining our scripts. Code changes, business requirements change, process change. We need to change, we need to kill, we need to create new automation scripts. But that's one thing, we need to kill our scripts. This is not easy to do because of infrastructure lock-in. We have installers. Sorry, I'm just getting a bit ahead of myself. We have installers. We install our binaries to our environments, multiple environments. They use PowerShell scripts to do this. If we want to change something for a specific PowerShell script, say it's service helper.ps1. If you want to change that, if we want to kill that, we don't know what will happen. We don't know which teams used it. We don't know what were the changes, and we really don't know how much components or how much services will be affected if we just kill one script. So this is the reason I think that teams should find their own tools and find their own processes. They do this organically. Teams self-organize. They decide on leaders, or at least they should. They should know their process, and they should decide on what processes they should adhere and they should build. And the same is true, or should be true, for tools. They should build their own tools. They should be able to decide their own tools. This is some of the tools we use. We use Cake for pipelines and PowerShell everywhere. If you see it, we use Jenkins for Jenkins. I don't know why Jenkins is there. Yeah, we don't use Jenkins, don't we? No, we use TeamCity. Yeah, probably. I'm looking for the future, but I'll talk that. Yeah, I'll get to that. We use some custom generic CI pipeline or Git hooks, or you name it. Some of the tools we use, but not all of the teams use these. And that's one of the things. And job is striked out in there because I don't think we should find the right tool for the job. We should find the right tool for the team. And why is that? Think about, we're developers in a Microsoft stack. So we're Windows developers, for all that matter. We use Windows VMs. We develop in .NET Core. We use C#. Let's say that our business changes and there's a directive that comes from the CTO down to the bottom that says, no, we're going to use Linux from now on because you're using .NET Core and all of the sky uses Java. So why are you just the Windows fanboys? Just move along, get to Linux. Well, okay. So what was the right tool to automate something in Linux? Probably bash scripting. We're not familiar with bash scripting, at least those guys aren't. I am. But they won't be able to develop in bash script. So they won't be able to develop bash scripts or any of the other tools. They're not into it. They don't know the command. They have a large learning curve, and it will have a farther away return on investment because it has a high initial cost. Why not use PowerShell core, for example? It's the same stack we're used to. It's the same thing. We already develop scripts in PowerShell. It's just using PowerShell core because it's built on .NET Core and it runs on Linux and Mac OS, so on. The same is true for TeamCity. If we move all of our environments to Linux, why are we using TeamCity? We can't. We can't. It's Windows specific. So okay, just kill TeamCity and just spin up Jenkins, and that's the reason why Jenkins is there. No, it isn't, but it could be. We could use Jenkins to do this, to make our deployments, to make our builds. And why are we able to do this fast? Because we tried to do something prior to the fact. We tried to build our CI pipeline as code. And because of that, we're not targeting TeamCity directly. It won't be a huge change moving from TeamCity to Jenkins because we're just calling a PowerShell script, the same PowerShell script that probably runs in PowerShell core in Linux. So these are the tools that we as a team decided to have. It's not something that the CTO knows. It's not their domain. They're into Visio and building boxes and stuff, boring stuff. PowerPoint, yeah. So we can change all of these tools, or at least most of these tools, if we want to. But if we as a team have the need to change them, not if someone tells us, yeah, you have to use Puppet. Why? I can have some other thing. I don't like Puppet. I want another flavor. So don't do that to yourselves. Build tools that are specific to your process, the process that you know really, really well, and that you might be able to intervene when something goes wrong with the script, and build the tools that you can reason with or about, and that you are able to operate faster. Okay, don't be hostages to your own infrastructure as we are to our logging. Okay, don't be hostages to that same decisions. Automate things, yeah, it's cool. It's really cool. It accelerates teams and it accelerates individuals, and it has a lower time to market. But don't do it blindly. Okay, and that's basically it.